Hi, my name is world-yasir and I'm gonna talk to you about floyd warshall algorithm and the problem levenshtein distance or Reed distance. And the end of this presentation, you will know can we solve levenshtein distance or Reed distance using floyd warshall algorithm. First, we have to know what is floyd warshall algorithm. The floyd warshall algorithm is used to find the shortest path between all pairs of nodes in a graph. It's simple. It repeatedly updates the shortest path between two nodes by considering an intermediate node. It works on both directed and undirected graphs. It handles negative edges with weights, but not negative cycles. In essence or in conclusion, it systematically checks if a direct path between two nodes is shorter than going through an intermediate node and updates accordingly. So the second, we have to know what is the levenshtein distance or Reed distance problem. The levenshtein distance or Reed distance is a metric that measures how many single character edits or insertion, deletion, or substitutions are needed to transform one string into another. It's commonly used in spell checking, DNA sequencing, and text comparison. For example, to change K10 to setting, we have three levenshtein distance, which two of them is substitute operation and the last one is insertion. So the question is that does floyd warshall algorithm solve this edit distance or levenshtein distance? Uh, the answer is that normally for edit distance problem we use dynamic programming in problem solving because it's more optimally. However, if you think of the edit distance problem as a graph problem where each string represents a state and each edit operation like insertion, deletion, substitution represents a transition with a cost of 1, the floyd warshall algorithm could theoretically be adapted, not practically. So here is how to implement edit distance using floyd warshall algorithm. We have to assume that the problem is reimagined as a graph problem. Each possible state or string is a node. Each edit operation like insertion, deletion, substitution is an edge with a weight of 1. We compute the shortest path between the initial string and the target string using floyd warshall-like approach. So here we have the code to implement uh, edit distance using floyd warshall algorithm, and you can see here that we have some steps here, and I have an example here that uh, the living distance between kitten and sitting is 3, and I run the code and you can see here the result. So we have here the code tracing that shows the steps that we did in the last implementation in VS Code, and you can see here that there is 4 steps: initialization, base cases, main loop, and the result. And there is the dry run that shows implementing each step manually through our hand, and you can see here that the difference between kitten and sitting or the edit distance between two is